Hey folks, I'm Robert Quinn, your semiconductor industry ambassador. I'm here at the Texas Semiconductor Summit. We just got to listen to Chris Miller speak about, Chris Miller, the author of Chip Wars, talk about geopolitics, supply chains. Just ran into Lex, and Lex is with SecureFoundry. Lex, tell me about what you're working on, what you're doing. It's really amazing seeing this semiconductor industry evolving, and you know how the international collaboration of it all is happening. I love the story about how you came to the technology that you're bringing over.
Yeah,
and
it's a fun story.
Tell me about your company.
Yeah, so the story was when I left the military, started commercializing tech for the Pentagon, right? Anti-tamper chips, post-quantum encryption, things like that. And I was a little bit frustrated that I didn't have this manufacturing line anywhere available to do these lower volume, high value manufacturing capabilities. And that's when the Pentagon turned me on to this really great technology that was struggling in Europe. So we eventually split the company with ASML. They took the workforce, we took the technology, domesticated everything to the United States and picked up development. And yeah, and it's just been a wild ride since then.
That's amazing. So tell me about this technology. What is the difference in this technology, and how is it, without going too overboard with the technical jargon, what is the technology, and how is it going to change the industry in the future?
Right. So at its core, the technology is a multi-E-beam system, right? Okay. So we're very familiar with single beams, lithography. There's even multi-beam. They got like 9 beams, up to 20 beams. And then we have 65,000 beams. So you're really starting to talk about massive throughput. And so for us, it's a pretty big game changer. There's no limit to the field size, so we can do an entire wafer. It's been demonstrated down to 22 nanometer nodes, 33 nanometer half pitch, 7 nanometer overlay. I know you said not to get too technical, so that's as deep as I'll go, but we can do some really interesting things there. And so one of the really great pieces is that it's maskless. So it changes the entire process flow for us, so we can go quickly from design to fabrication and get these really fast iterations. And we're not even limited by masks on a wafer, so we can do multiple iterations of the same device on a wafer at the same time and really see what works. So for us, it's this massive, rapid prototyping capability that we can do these really iterative DoD projects and commercial projects, university projects, and it's really nice because you don't have the mask cost either, so you kind of get that freedom.
And you know, one of the things I keep talking to people about, I was just having a discussion with Naveed Swani, and a CEO of a large company that's doing FPGA, and you know, how do we increase the speed to market? And you know, we have this tsunami of technology moving into us right now.
Yeah.
And you know, there's going to be so many devices, from IoT devices and everything. How do we increase that from the amount of time that it takes right now to go to market? And it sounds like you're providing a solution for that. And you know, so we can actually, you know, speed up this going to market for companies such as IoT devices and other organizations.
Yeah, and for us, it's not just about speeding up the time to market. It's also about removing barriers to entry, namely being the mask costs, right? And then the time it takes to get a mask made. Yeah. And then the time to wait for a multi-project wafer run if you're doing small volume kind of MVP. We want to change what the roadmap looks like for commercialization, prototyping, iterative processes, so that we can just really open the floodgates for all these new technologies.
Right.
And we offer advanced nodes down to 22, and we have a roadmap to go sub 10. But companies can do these advanced nodes without having to get into a big fab to get them. They don't have the volume requirements to get there. They don't have the mask cost to get there.
Right.
And so that's really where we're positioning ourselves, right? Trying to compete with ASML on high volume is nowhere on our roadmap. We really like the idea of owning that niche, of being the enabling technology that allows a floodgate of new technologies to enter the market.
That's amazing. And that's really what we need right now, in trying to bring this new technology. and then the cost savings too. I mean, the cost savings have got to be quite a bit as well.
There are, and I think if you want to compete with China, right, you're going to have to attack it on the economics of it. It's not just having capacity where we're building more fabs, but you're going to have to attack the economics, or you're just going to be stuck in an endless cycle of subsidizing big fabs, right? Because you've done nothing to change the economics. And I think there's a lot of really interesting new technologies that are hopefully going to attack the economics to make us competitive. I think Substrate made their big announcement yesterday, so that might be one of those technologies where we can, again, attack the economics.
Absolutely. That's amazing. Well, thanks so much for joining me today, Lex, and I'd just love to be able to talk about the next evolution of technology, where the semiconductor industry is going and who's doing what. Sounds like you're really attacking that and making the solutions for that. And thanks for joining me today.
Absolutely. Thanks for having me.
Hey, thanks, y'all. Have a great day. Bye.